timer to keep myself from getting the light at the end. All right, cool. Yeah, I'm really excited to be here, seeing tons of familiar faces, and yeah, BioIT World's always great to connect with people and see all of our friends and colleagues, ex-colleagues. Cool, so this is gonna be a very different talk from the last one. This is gonna be much more technical and tactical. I also have to confess I'm filling in for one of our founders, Chris Dagdigian. He couldn't make it, so I'm giving his presentation. So using someone else's slides is always kind of an interesting experiment. And yeah, Chris has this particular style of presenting. So in this slide deck, I actually have 141 slides. And I don't think I'm gonna get through them all, but that's classic Chris, is having way too many slides. And also I've kind of built a career off of trying to mimic Chris Dag. So we'll see how this goes. So anyways, this is a talk about Parallelcluster, something that we use in bioteam consulting all the time. I think it's a really important design pattern for general purpose workloads, in life sciences and across other scientific domains. So, HPC clusters are here to stay, and I'll kind of talk about how we use them at Bioteam and some tips and tricks. So again, quick sort of background about me. Again, I think, I've been in this field since roughly like 2005. When I came out of college, the dot-com bubble was kind of bursting. And so I sort of found this new passion for, biotechnology and sort of personal health. And so I spent my formative years at the Pittsburgh Supercomputing Center. That's where I kind of cut my teeth trying to use the big supercomputers to work on protein structure prediction and other modeling and simulation. So we had a Cray XT3 at the time, had to learn Unix. We were doing things like QMMM simulations. So I needed to use these big machines, right, to get my job done. We also built things like a training center for people to learn bioinformatics on supercomputers. So to me, HPC and supercomputing is sort of fundamental to computational science and to how we do science today. Next slide. All right, so again, I kind of pivoted away from sort of getting my PhD at CMU, and I met these guys at the bio team. I think Chris actually posted a job on bioinformatics.org job board, and I was just like, this sounds like my dream job. And so they gave me a shot as sort of a young kid coming out of the PSC. What was interesting is right around that time, Amazon launched this new service. I think it was even in private beta. It was, EC2. It was just EC2 and S3 at that time. We had this interesting problem at Pfizer where they were trying to run their antibody modeling pipeline, but they were running out of space on their local cluster. So they said, can we use Amazon for this? And they kind of asked a similar question like most scientists were asking at the time. Hey, Elastic Compute Cloud, great. How do I submit my job? And you go, oh, well, it doesn't really have a job scheduler. You're just getting instances, right? And so it was kind of very hard for people to sort of map, their workloads onto EC2 at the time because it was just raw EC2. And so what I thought was also interesting was this idea of the elasticity, though, because HPC clusters, you build these big machines, and most of the time they're more than what you need, right? They're too big, they're sitting maybe partially idle, but then when you really, really need them, they're probably not big enough, right? So that was a very attractive concept to have elastic computing. So if we could just sort of map our supercomputing onto these hyperscale architectures, I thought it was pretty compelling. And so that's kind of why I've been sort of a cloud evangelist ever since. So in those early days, there was nothing to turn Amazon into something that looked like an HPC cluster. So I had to kind of write a job distribution pipeline from scratch using things like SQS and S3. Again, if you're interested in the science we were doing, it was looking at protein-protein interactions, trying to model sort of new antibodies using Rosetta++, which is a common framework at the time. So that was very successful. And James Hamilton, who's sort of an OG behind the scenes at AWS, actually blogged about us, which I thought was a pretty big deal at the time. All right. I'm not going to tell you too much about Bioteam. We've been coming to this conference for all 21 years that it's been in existence. We're sort of an interdisciplinary team. Most folks are domain-specific scientists, from genomics, from physics, electrical engineers. So all of us have sort of a strong scientific background, but then we leverage advanced technology. So we have things like HPC architects, cloud engineers, and we sort of have a great, broad, deep team. Again, I don't want to talk too much about Bioteam. Our mission is just simple, accelerating science, marketing. All right, so why do we, you just saw this cool presentation from Amazon, how you can just click a button and run your workflow. Why do we still need HPC clusters? Like what, who cares, right? Isn't that old news? I would say actually, no. I think cloud marketing has sort of, told us that everything is going to be, rewritten for the cloud. It's going to be cloud native. It's going to be serverless. You're just going to click a few times and run your workflows. And I think the reality is there are hundreds, if not thousands of applications that we're using that are never going to be rewritten for the cloud, right? They're running on traditional HPC and they're going to stay that way, right? No one's going to spend the time to sort of rewrite these things from scratch. And while I love sort of DevOps and this idea of infrastructure as code, I don't think that's reaching all the way down to the level of the scientists, right? I don't know that we're getting scientists to write everything in CloudFormation. And so I think this is really still a huge long tail of science that needs this kind of architecture. Also, I think like there's a lot of, cloud engineering and cloud specific skills you need to do this stuff. And not all organizations are staffing themselves with lots of cloud engineers and DevOps engineers. So that to me is a problem. And that's why we still need this sort of traditional looking HPC, but I'll talk about why it's actually still a bit different than on-prem HPC. So again, I think this pattern is not going away. We're not going to rewrite all of these things. And, oftentimes even the software itself needs files and folder structures, which Amazon will tell you everything should be in S3 and in object storage. While I love object storage, all of our software is still going to be looking at POSIX files and folders. So that's not going to change. And there's just people need this experimental environment. They kind of want to write ad hoc scripts in Bash and in Python. And so again, fully automated end-to-end workflows and some domain-specific language are great, but I think the HPC cluster is still sort of the fundamental tool. It's almost like the microscope of computational science. And I think, again, we don't have a lot of cloud engineers sitting side by side with scientists. So asking them to work in this new sort of managed serverless way, I think is too much, right? They need to focus on their science. And a lot of scientists are actually coming from careers in academia or at research centers. They're used to this kind of resource, right? They're used to using a big HPC cluster. So why not give them something that's more like they're used to so that they can still do their work and stay in the flow of their research. So we're talking about Parallelcluster today, which is an open source framework from AWS. It does give you that traditional HPC environment. Bit of history here. So I remember when I first came to BioTeam, we had a Perl script. It's called ec2.pl. And it would actually run when an EC2 instance booted. It would scrape the EC2 metadata, and then it would run a Sun Grid Engine installer across a bunch of nodes that had passed around key pairs. That was like the first version of like creating a grid engine cluster on Amazon. And then something came along from MIT called StarCluster, if people remember. This is like ancient history. StarCluster was a thing for a while, and that was an academic project that actually did that job pretty well. Then someone at AWS decided to rewrite it in CloudFormation. It was called CFN Cluster at first. So that was like a solo effort at AWS, which then turned into a full-fledged open source effort called Parallelcluster. And now this is actually an active project that has new features released. It has pretty good support. And it's really sort of easy to transition to if you're looking for this type of architecture. So again, the goal of this talk is to just sort of tell you some things we've learned from using this in real clients. It's something we use all the time, and this is going to be sort of very sort of practical, tactical in the trenches, okay? So the big thing, though, is I think changing your mindset about how you think about an HPC cluster. When we have those big supercomputers, those big resources that are going to be shared by lots of researchers for different workloads, the mindset is you have to kind of commingle all those workloads, right? You've got people that need like large memory, they need GPUs, they need high CPUs, right? And so a lot of the job of an HPC team is really balancing that diverse workload that comes in from all their users, right? And if you go to any of the supercomputing sites, they do a lot of effort in figuring out how to serve their users better with their HPC resources. And again, I see a lot of clients who have a lot of effort into sort of how they set up their queues and their partitions and priorities and projects, right? And so like sharing a big resource is a complicated task, especially as the science gets more and more complicated and the workloads are more complicated. So that all takes a lot of time. And then you have to think of the whole hardware refresh aspect. People want fat nodes, people want GPUs. Again, like, so this is what, sort of HPC is all about. What's different about when you move this HPC to the cloud is that you no longer have to think about putting all those workloads on the same cluster, because in AWS, one big cluster can also be split up into a bunch of small clusters or a bunch of big clusters, right? You don't have to think about sort of the fixed size infrastructure anymore. And so that lets you think about clusters differently, honestly. Now you can have one big shared cluster if you want and keep doing things that way, or you can have a cluster per use case, or a cluster per department, or a cluster per team or region, right? So you can really just think about clusters in a new way because they're virtual, right? And you can spin up more if you need them. And also the auto scale, we'll talk about sort of some of the features of Parallelcluster, but this is, to me, is like the biggest mindset shift when you go to AWS-based HPC, is that you don't have to do things how you did it before, but you can still support all the legacy workloads, if that makes sense. So one of the things they'll tell you with sort of these cloud-based setups and CloudFormation setups is that you kind of, everything is ephemeral, right? You're going to spin up a cluster and you're just going to tear it all down when you're done and clean up after yourself, right? And that is fine for workshops and demos and one-offs, but really I think you have to have some persistent architecture, which I'll talk about. And, a lot of times, again, like the previous talk, Omics is great. Omics is really cool. All that serverless stuff, one click to run a workflow is very interesting. But it's not exactly realistic for our clients in most cases, right? I think they still have a lot of this just sort of legacy stuff, and they're not writing Lambda functions. They're not sort of doing everything serverless. They're just people who know how to use an HPC cluster and they want to get their science done. So giving them, Parallelcluster, I think is a smart path to making them successful. So again, things that should stay persistent though in a Parallelcluster, I think is, your identity management. So rather than sort of bring everything up and have everybody run as like root or EC2 user, you want to have some sort of identity management strategy so that your, users and groups and things are sort of consistent across clusters or even across life-cycled clusters, right? So you can bring up a cluster, tear it back down, but you want all your identities and things to stay intact. Same with home directories, right? This is just a convenience where people are used to having a home directory that has their stuff in it, and they come back to, even though if they're launching multiple clusters, they come back, all of their existing files and folders and configs are there. And then applications. Again, there's a lot of ways to manage applications on HPC clusters, but having some sort of file system where you keep all of your applications, probably in environment modules. There's lots of ways to install them. I'll talk about, different ways that we like, but this is the stuff that should be persistent. So this stuff can have a separate life cycle from your HPC cluster. So clusters can come and go. This stuff should be persistent and available for your users across cluster instances, let's say. Identity management is a big space. We could talk a long time about it. There's lots of ways to do this. In Parallelcluster, I would say there's a few obvious ways. They do have sort of native Active Directory integration with LDAP. So you can just put that in your YAML config and you'll get sort of LDAP over AD pretty easily. You can also just do things like script your user creation. So maybe you pull down a list of users and every time a cluster launches, you're going to create those users and groups in a very simple script. You could also do other custom actions. I'll talk about custom actions. You can do some weird stuff like just copy your Unix configuration files out of S3. And you can also build images, which is kind of a classic way to customize these that I'll talk about the trade-offs about in a minute. All right, so for home and apps, again, if you want a persistent disk or a persistent file system across your clusters, I think using EFS is a really good starting point. It's very simple to use. You just provision it. You don't have to request a size. It's essentially just grows as you add data to it. It's just NFS v4 under the hood. And it's really easy to set up. It just works in Parallelcluster. It's like a 2-line configuration. The only thing is you will run into some performance issues with EFS if you push it, right? High IO use cases will definitely need some EFS tuning, and EFS tuning can be kind of tricky. Like there's AWS folks who could probably tell me how to do it, but it seems complicated. And so I like to start with EFS, but then as you sort of need it, you can move to things like FSX Luster or other faster file system options on Parallelcluster. The other thing about EFS I would mention is that due to its sort of infinite nature, scientists will just start loading up tons of data, right? They'll just start filling it up. I know Jason from row here has experienced this, but they'll just add data forever, right? And this is kind of one of our bio team talking points is that, scientists really are not great at managing their data, and you really have to almost force them to own their data management, and that's a difficult battle. So you're going to have to think about life cycling and snapshotting that stuff, and it will get expensive. So a bit of data hygiene here would go a long way, and EFS can kind of be problematic in that it looks like it's 8 zettabytes or something when you mount it, and they just kind of go crazy with that. All right, so other things, this is just kind of a screenshot. Again, this is some setups that we had where we're showing sort of that we have consistent IDs coming from LDAP, also that we can sort of load software modules from EFS, and also again making multiple versions of software available. This is really common in HPC where you've got a module system. This is showing different versions of NAMD. And again, this is the experience that I think most of our clients actually expect when they want to do cloud computing at scale with, and it needs to be that easy for them. All right, so summarizing just that little section, again, it's a kind of a mental shift to think about your HPC stack and how you might want to how you might want to deploy them, whether it's for a specific use case, a specific group. They can be tweaked in terms of their hardware, right? So you can really get, pretty application specific with clusters, which I think is something that you don't traditionally do with a large HPC cluster. And again, even though everything can be disposable in AWS and you want to shut things down, think about the essentials that you need to kind of keep running so that it's, again, a smoother experience. You've got consistent identities, people have home directories, etc. Fast here. Okay, so this is just some things about node configuration. So again, if you're putting all your software in a consistent file system, your usernames are coming from a central authority, then that's a pretty smooth kind of like, you don't need to configure much else, right? You've got users, you've got software, but there's always extra stuff, right? There's always little tweaks and things you have to do on an HPC cluster. And so there are lots of ways to do that in Parallelcluster that I want to tell you about. One thing is just to, well, this is just some examples of things we might do actually. So installing extra packages, right? There's always a need for like, hey, I need these R modules. I need to have this other piece of software I just discovered yesterday. So one easy thing is to just, add environment modules to other directories and add that to the end of your configuration files. There's other tweaks you might have to do to LDAP, your DAG specific things. So it used to be harder, so the way you used to configure new cluster images was you had to kind of roll a new AMI each time you wanted to update the software, right? And that was kind of a pain. I mean, you could do it, but like you had to take like the specific CFN cluster ID, launch it, customize it a bunch, snapshot it, hope the next time you launch a cluster it worked. It was a pretty slow process. And then later on in Parallelcluster 2, it could sort of do a self-install onto any AMI that you give it. So that was a really nice way to sort of bootstrap itself onto images. And now they have these really convenient custom actions, which let you you have hooks now into the cluster creation process where you can do all kinds of customization, which is, again, super useful in our clients. So there's no problem with, creating AMIs or creating images in this environment. And in fact, if you're trying to do sort of a production or a hardened environment, I'd probably say, making, golden images is probably a good strategy there. But the problem with that is that now you have sort of the stale image problem where people are going to be running an old version, or, they need something new and now it's not compatible with the latest Parallelcluster. So again, you get into this sort of image building dilemma of always having to rebuild images and kind of keep the versions moving forward. So that I would say is not the best practice anymore. And you really want to try to move as much of that configuration management into the bootstrapping process, let's call it. So that's where custom actions come in. You have a couple hooks that they give you on node start is obviously when a node starts up. This is a good time to do sort of like OS install stuff. This is, again, before the scheduler is installed. On node configured is sort of after the scheduler is installed, which lets you do sort of Slurm configuration. So Slurm is like now the de facto standard for job schedulers, I guess, especially in Parallelcluster, but pretty much universally now. And that's the time to tweak your Slurm configs is on node configured. All right, so one method we like at BioTeam is using Ansible. So it's kind of a slick way you can use Ansible to pull its playbooks directly from code commit, which is a hosted Git repository. So now instead of having to like bake all that config into either shell scripts or other kind of custom scripts, I can sort of host my customization playbooks in AWS. And then when the cluster starts up, I can pull them down and then run those playbooks on the nodes. And this is kind of a nice pattern. Let's talk about why. Again, Ansible is really easy to use in terms of configuration management. I've went through the whole sort of like Puppet to Chef to then, Ansible. I mean, there's a lot of these tools. I actually really like Chef personally, but it required you to know Ruby and it was like a domain specific language. Ansible is just YAML. And so I find it's a lot more approachable for scientists. And you can also use Ansible across the rest of your infrastructure. So you can use Ansible to configure, regular servers, workstations. You can install just sort of single one-off things with Ansible. So I guess it's a good tool to standardize on for configuration management, and also works really well in sort of the Parallelcluster landscape. So that's just kind of a recommendation there. I would say between Ansible, if you're thinking of another option, Chef is part of Parallelcluster. So if you want to overload their Chef cookbooks, you can also do that if you're a Chef shop. So again, how that kind of flow works is that you have your Git repository up in code commit. Probably could be in GitHub, but code commit kind of puts it in the AWS account for you. And then you just put your Ansible playbooks in there. You do need some sort of IAM policy tweaks to let it pull those playbooks down. But then you can have Parallelcluster kick off the Ansible run. and the nodes will sort of self-configure as they boot. So this is just a very useful pattern. Requires a little bit of IAM configuration, and also you can do it. You can add other things into that configuration. So if you may want to sort of pull down secrets or keys at the same time. And then, this is just sort of policy stuff. It's a little boring. All right, that's a script. I won't make you read it, but it's essentially like this is a custom script to run Ansible and and bootstrap your cluster. Again, all these slides will be available, so I'm not, don't worry about reading the code right now. One sort of wrinkle in this is that often you have a multi-account strategy in AWS. So you might have central accounts or shared service accounts. So you can still have your Ansible playbooks or whatever your configuration management you're using in one AWS account, and then have clusters in different accounts. Pull that down. That's just a little tweak to your IAM roles, and then you can do some little SSO credential tricks there with that link. All right, so let's go a little deeper into the Ansible strategy here. Again, Ansible is pretty approachable. You've got sort of a main entry point, which you can then sort of include a bunch of other specific playbooks. And that lets you sort of just carve out like little tasks of configuration and apply them to a cluster. You can also tag them. So if you only want to run certain playbooks on a cluster, you can use tags to when you start the Ansible run. And this is, again, if people know Ansible, this is probably boring. But again, for things like installing packages, it's really simple. Like when you need extra packages, you're just adding one line, right, to a list in Ansible. It's about as simple as it gets. And Ansible is smart enough to use Yum if you're on a Red Hat distribution, use apt-get if it's on Ubuntu, and basically is pretty smooth as far as getting things configured. Again, other little things we customize. You might customize your message of the day or your login banner, right? Maybe you have sort of I don't know, terms and conditions. Usually some scary warning about you're going to get in trouble if you do anything bad on this system. Users login, let's skip that. Environment modules, again, something that people just expect when they're using HPC. So one way that Ansible makes this easy is that you can just add a line to the end of your module config to add those new paths that you set up in EFS. So you say, hey, also look for modules here, and so that's an easy way to sort of bring a bunch of modules for a use case to a cluster with just adding a single line in Ansible. Again, it's just showing some LDAP tweaks. This is kind of the stuff that, again, we end up having to do for clients because there's always little things like you want encrypted LDAP, right? Or you have to create a group ahead of time because they exist in your central directory, but they don't exist in the Unix local groups. So again, little tweaks that sysadmins or sysops would make made pretty easy here, even though it's an ephemeral cluster. Again, throwing people in sudoers is a common thing, right? Everyone wants root, and so you have to find a way to throw them in the sudoers file. Again, this is just really practical stuff that I think we end up doing over and over. And I think, I'm certainly of the philosophy that scientists should be able to sort of control their environments a bit more. And so again, I think allowing them to self-install packages and do things is important. And so you can sort of give them this autonomy without with a limited blast radius, let's say, because they're only going to affect their own cluster. And this is why giving single user clusters or single group clusters is great, because this is the kind of stuff you could never do on a big shared resource. Nobody's getting root. You're going to open a ticket to have an admin do something for you. This puts the power in the hands of the scientists. I think that's important. All right, so just another little recap. While you could just sort of launch clusters with minimal configuration, the reality is that you end up having to always tweak the OS and always do little customizations. But that's actually really easy, right? You can do it with this, the latest parallel cluster has these hooks called custom actions. And inside of custom actions, you can put a shell script, you can use Ansible, you can use really anything you want to configure your nodes. And that's great. And we have examples that we can share on how we use sort of a hosted Ansible Git repository from code commit pulled down to configure your cluster. All right, other just deployment considerations are if you're thinking about using Parallel Cluster, again, it's open source, it's free. All you need is an AWS account to use this. You need the Parallel Cluster, client, let's call it, or the tool, and that can go inside of a Python virtual environment. What's nice about that is that you can sort of maintain different Parallel Cluster versions, because sometimes they make breaking changes when they upgrade versions, and so you may need to manage clusters with older versions of Parallel Cluster. So just advocating Python virtual environments in general. And yep, that's all we have to say there. While it's very easy to launch this stuff off of your laptop and your config files can be local, I wouldn't recommend that, mainly because you need that YAML file to interact with that cluster. And so putting it, I think even there's a feature now in Parallelcluster that lets you just host that config file in S3. But if not, S3 is a good place to stash that config file so that even if someone's laptop is not around, you might be able to still talk to their cluster. Also, you could have, say, a little EC2 node that's kind of like your command and control node for clusters. And that can be just like a micro instance where it's really just, your HPC operations node, and it can launch a bunch of clusters and maybe all the config files live there. There are lots of ways to do this, I guess, is the point, and flexibility is great. And again, I would say S3 or a Git repo would also be a great way to handle config files. All right, there's this idea, I guess, in Parallelcluster that you're kind of giving Parallelcluster admin level permissions when it launches. And that seems problematic, especially when you go to your cloud team, you're like, hey, I want to use Parallelcluster. Also, give me full access to this AWS account. And they're kind of like, I don't know if that's a good idea. And also, I'm going to hand it right over to a scientist, right? That seems problematic. But I think, the alternative is like creating these really complicated IAM policies where you list out everything Parallelcluster needs. And then there's permissions that launch the stack versus be able to run the stack. And I think there are ways now in Parallelcluster 3 that you can sort of launch it with admin level permissions, but then Parallelcluster itself will scope down its IAM role. So again, I'm still a fan of like the principle of least privilege, but Parallelcluster kind of handles this better now. And I think you could definitely control this now in Parallelcluster 3. You can also put it in like maybe service catalog or something if you really wanted to lock down how people can launch the cluster. So you put it behind service catalog, that'll give you more granularity in your permissions. But there's a lot of ways to think about this if you're sort of a cloud ops team thinking about the security. This is another good thing for security and also just added capabilities. So they allow you to sort of attach additional IAM policies to your CloudFormation stack. And so that can give you all kinds of extra permissions, like permissions to S3 buckets or permissions to talk to other services. You can give it, again, read-only access to things. You can let it look up secrets. You can do a bunch of things. And so, again, look at this additional IAM policies as a way to sort of layer on your additional policies and capabilities. All right, tagging, we've been using the cloud now for 15 years. The ability to tag stuff is kind of important at this point, given how much has moved to the cloud, right? Tagging and having good sort of visibility and monitoring into your stuff is great. So this is just sort of a good practice, is to always tag things. Parallelcluster lets you do it right in the config file, so there's no reason not to start tagging things. Again, most organizations are doing this, and they can do things like show back costs and show budgets and things like that. So again, use tags. It's a good thing, and it's easy to do. So no reason not to. Here's some example tags. I'm running out of time, but there's some nice monitoring now in Parallelcluster. So before, I think they would have it disappear after 14 days, but now you can turn it on and like retain those logs. Again, having good logs from Parallelcluster is good. I'll also talk about Slurm logs and the benefit of knowing what your jobs are doing. I'm going to skip LDAP stuff. All right, so again, to recap, pin-specific Parallelcluster versions with virtual environments, because they will only be able to control certain versions of Parallelcluster clusters. Make those config files accessible by more than one person, so don't leave them on people's laptops, or else you might have clusters running that you can't control anymore. Think about how you want to handle IAM, right? There are ways to do sort of well-scoped roles, but if not, you can sort of layer on additional policies. And again, I've had Parallelcluster work at some of the most sort of security constrained environments. So like you can make it work despite whatever kind of guardrails you're thinking about. Tagging is great. Look at monitoring and think about how to use monitoring. If you want encrypted LDAP, there are some sort of extra things you have to do, like put a SSL terminating load balancer in between, but those are just technical things. And Bioteam can help you if you need. Post-deployment. Okay, so a couple other things as I wrap up. It's nice to turn on sort of job accounting in Slurm. This lets you sort of look at how jobs are doing with memory and runtime, and how are they exiting cleanly. This is good stuff for just you to have to look at how jobs are performing, especially if you're buying expensive nodes and you want to know, am I using these resources efficiently? The more sort of job accounting you can turn on, the better. You can do that by sort of setting up an accounting database, which I think is in here. Yep. So here's some details on how to configure that. Again, you get things like memory utilization, so you know if you're kind of using the right instance types. This is just good data to have if you're going to optimize these things. You used to be able to do this with a file-based accounting in Slurm, but they discontinued that or stopped support for that. And so now you have to set up a MySQL database. Very easy to do in AWS. You can just use RDS for that. There's a REST API for Slurm. If you want to do Slurm federation or cloud bursting or something like that, then setting up the Slurm REST API is important. There are ways of putting cool front ends. Parallelcluster itself has a front end, and that's something that if you want to have a UI for this stuff, Parallelcluster released one. And let's see, recap. And then finally, I'll just mention this. This is the other slides I have, but if you want a really interesting front end to put on all of your Parallelcluster clusters, RStudio, which is now called Posit Workbench, has a launcher that will actually talk to Slurm and launch your notebooks onto Slurm jobs, which allow you to sort of use an auto scale. I'll just give you the cool graphic. Now have an RStudio server essentially that launches your notebooks onto clusters, which can have multi GPUs, which can run parallel jobs and do all that good stuff. So this is a great front end for Parallelcluster. We have a webinar about this. Check our website. We actually have 3 Parallelcluster webinars with all this content and more done by Chris Dagg, who does a great job at this. And if you want more on that stuff, just come check out our webinars and give us a call. Thank you. Let me know if you have any questions.